Okay, what is a PLC? A PLC is a programmable logic controller. It is an industrial computer used to automate and control various processes and machinery. So to keep it simple, a PLC is pretty much the brains of the industrial world where it controls equipment, devices. It pretty much is the liaison between the devices and the output that you want the equipment to do. So to begin, I'm using a Allen Bradley brand PLC picture. There's different brands. They look a little bit different, but they all have the same concept. First, you will have a power supply. So power supply is going to provide power to that PLC. Then you're going to have a central processor. This is where your brains is. This is what it uses to process information and develop outputs or whatever it is that you need the equipment to use. Okay? And then there are many different modules you can add to the PLC or different functions, but we're going to keep it simple and we're just going to do input and output. Okay, we have an input module here and an output module. And they call them modules because you can add more modules to this to pretty much you do any function that you need. Maybe you need to use an analog, maybe you need Ethernet. But for now, we're going to keep it simple. We have the power supply, supplying power to the actual PLC. We have the processor, which is the brain. We have our input, which is going to provide information or data. And an output is what you want the PLC to send out to make the devices or equipment to work. Okay, so generally, we use a PLC because it's very durable in the industrial setting. You know, it could withstand a lot of heat and it is very durable. So to keep it real simple, you have an input coming in, right? The input could be anything like a sensor or a push button. That input is going to be connected to the input module. It's going to be terminated to the input module. Okay? That input, whenever it's turned on or off, whatever state it is in, when it is turned on, it's going to send a signal to the input module. Inside that input module, this is where your processor is taking that information as a signal. And it takes that information, it does what it needs to do, which is then it sends out a output to a output, which can be a light to turn a motor on. So let's keep it simple. We have let's say a switch or a push button, right? Okay. And here we will have a light bulb. Okay. So what the PLC does is basically a small computer. It takes information, it takes data, and then it sends out, it makes something else work with that information. Just keep it simple. Okay. Let's say you want to turn on a light in the room. Okay. You push that button down. Now it was off. Now that it's on, this PLC receives that information from that push button. Hey, it's on. The processor takes that information And as the user, when you program this PLC, you're telling this PLC that, hey, when I get a on signal from that push button, I want you to turn on this light. Okay? So you get the input push button turns on, the processor processes that information and then sends a signal to the output to tell it to turn on this light. And now the light turns on. Now you turn off. Let's say you turn off the push button. Okay, now the push button is off. There's no connection. Now that the input is off, the processor should reason and say, oh, it's not on, so I'm going to turn off this output. Now the light is off. So it's real simple, real quick. The PLC is the brains. It's a computer that takes information from the input, and then it could be programmed to send an output which makes something work. And your responsibility as a user is you're going to program this computer to make it do something, right? At the end of the day, it's used in an industrial setting to automate equipment. So, for example, another example would be you have a door. Okay? The door is open. You have a signal, the input that says, I want this door to close. You push that button down. Currently is 0, right? Currently is in the off state. You turn it on. Now it's on. It's on the on state. Sends a signal to the input. The processor does its work. Then, because you program it to tell it to close the door when there's an on signal, the processor processes that information and sends out output. This output shuts the door. Okay? And now that door is closed. Let's say you turn off the input, and now that door opens. It only closes when you're telling it, when you're pushing a button, because you program that processor, you program the PLC to do that. It could be the opposite. It could be the door closes when it's off. It depends on how you program it. That's why the PLC is very flexible. It's quick. You could change it, before you have to hardwire these things. Maybe you have to hardwire to the door. Or let's keep it simple. Before, you have to hardwire to the light. Okay? So when you turn it on, the lights turns on. When you turn it off, the light goes off. There's only one way to do that, right? And if you wanted to do the opposite, you have to rewire it in a certain way so that it does the opposite. That's why the PLC is a much better option, because you can just send an input, send an output. And then, however you want to configure it, you could configure it by programming the PLC to do what you need it to do. You could even add a timer. To this input. Let's say you want to turn it on, but you don't want to turn on the light until 10 seconds later. And you could do this all in the program. When you're programming the PLC, you could create this program to say, hey, when I turn this on, I want you to wait 10 seconds and then turn on the light. And that's the beauty of the PLC. You could configure it certain ways, you could program it certain ways, and all you need is one signal in, one signal out, or one wire in, one wire out. And instead of doing hard wires here, changing the wires there, changing this, and it makes it really complicated when you have to change things, or even when you have to troubleshoot why the light is not turning on. Instead, you could go straight into the PLC program, look at what condition does it need to turn on the light, why is it turning it on, or why is it turning on, and then you could figure out the issue there, and then that's a simple, you know, definition and explanation of the PLC and why it's used a lot in industrial settings. Because unlike, a household, you could just turn on the light on and off. But in industrial setting, you're controlling many components. You might be controlling a pallet that's moving left and right, that lifts up and down, a gate that opens and closes, a light that turns on when it's on, light that turns red or when it's off. There's many factors and variables that happens in the industrial setting and automation that you will need a PLC to pretty much uh, be programmed to do all those jobs all at once, and it all can be done in one program, one PLC. And this is just to keep it simple. It has one input, one output, and it's modular, so you can add many more inputs, you can add many more outputs when you have many components and devices attached to this PLC. And the processor takes all that information, and it does it does the work for you. So that is the overall explanation. Um, I'll go into more details as there's more questions, or if I when this gets more advanced. But for the most part, just know that the PLC is the brains, the computer, on controlling the equipment and the devices on on the floor. And to simplify it one more time, it takes a signal, information, data, whatever you want to call it. It processes that information and how the user wants to use that information. It will output what it needs to output. Usually turning on something, turning on a light, turning on a motor, shutting something down, turning something on, and that's the overall view of the PLC. Thank you for watching my this video. If you have any questions, please leave them below. If you have any more input to make this video better, or more information for people that's watching it, I would appreciate it. I'm just doing this channel because when I first was trying to learn about automation, things were getting kind of confusing, don't know where to start, and I want to simplify as most as possible. And as more videos come out, I'll get more straight to the point, and try to provide information that you would need that will help you in your journey to learning automation. Thank you so much. Bye bye.